In this video we will show a useful identity. We have a symmetric domain from minus L to L. The domain, this interval is symmetric, and the function f is f of minus x equals f of x. The function f is an even function for every x belonging to this domain curly alpha. And we want to show that the integral from the integral over the curly a from minus L to L of the function is 2 times the integral from 0 to L of the function f of x dx. We have the integral from minus L to L f of x dx. We can split this integral from minus L to 0 plus the integral from 0 to L f of x dx. Now we take this integral from minus L to 0 and we set x equals minus u, so u is equal to minus x. We change the bounds of integration. For x equal to 0, u is equal to 0. For x equals L, minus L, u is equal to L. So this bound, the lower bound of integration is L and the upper bound is 0. X equals minus u, so it's minus u inside the argument of the function. Du over dx is minus 1, so dx equals minus du, minus du. And this can be written as the integral from 0 to L. I flip the bounds of integration with a minus, and with the minus inside the integral becomes a plus, f minus u du. But I know that the function f is even, so this should give f of u du. So I go here and I put a star and continue. So I have equals the integral from 0 to L f of u du plus the integral from 0 to L f of x dx. Now I can switch the first integral here, I can switch back to x, so it would be the same thing, 0 from 0 to L f of x dx plus from 0 to L f of x dx, and this should give me 2 times the integral from 0 to L f of x dx. So the integral over the curly a is twice the integral from 0 to L f of x dx.